Now let's move on to talking about our next type of hypothesis test, or two independent samples t-tests. Two independent samples t-tests can be used in different situations than one sample t-test and for different purposes. Previously, we used both one sample z-test and t-test using sample data to make a decision about an unknown population mean compared with a hypothesized value. We had an actual value that we wanted to use as our comparison to test. What if instead we want to compare two samples to each other? In this case, we are hypothesizing about the two populations from which the two separate independent samples came. When we say independent, we have no reason to suspect the samples or underlying populations have any impact on each other. For example, if we took a sample of men and a sample of women and wanted to compare them, unless we had done something special to match men and women, we would have no reason to think that values in one group depend on the other. We'll talk about another type of hypothesis test to use when we are working with related samples shortly. Keep in mind, when we say separate independent samples, the two groups that we are comparing can be two separate groups from the same sample we drew from a larger population. We just have to have separate groups that we are comparing. For example, men versus women, or people who were vaccinated versus those who were not vaccinated. The assumptions that our ability to conduct a two independent samples t-test rely on are that both underlying populations are normally distributed and both underlying populations have equal variances. Two independent samples t-tests are often conducted in experimental studies. For example, we might use a two independent samples t-test to help answer the question, does a group taking a new medication report fewer headaches than the group not taking the new medication? Or maybe, do people who have received a new influenza vaccine have a lower risk of developing influenza than people who have not received the new vaccine? Just as before with a one-sample t-test, if we don't know the population standard deviations from which the two samples were selected, we must use the sample standard deviations as estimates, indicating the t-distribution should be used, and we should conduct a t-test. Let's look at the process of conducting a two independent samples t-test. If we are comparing two independent samples to each other, the null hypothesis will be that the samples came from two populations with the same mean. Instead of writing this as mu1 equals mu2, or the population mean of the first group equals the population mean of the second group, we can rearrange the null algebraically to refer to the difference between the two population means. If mu1 equals mu2, then moving mu2 over to the other side of the equation would give us mu1 minus mu2 equals 0. This will give us a value of 0 to test. It tends not to matter which population mean you designate as mu1 or mu2, just as long as you are consistent with your research question, hypotheses, and calculations. We'll explore these further shortly. Just as with one-sample tests, we can do both two-tailed and one-tailed independent samples t-tests. The null hypothesis in a two-tailed two independent samples t-test is mu1 minus mu2 equals 0, and the alternative is the opposite, or mu1 minus mu2 does not equal 0. One-tailed two independent samples t-tests with an upper tail rejection region have a null hypothesis of mu1 minus mu2 is less than or equal to 0, and an alternative hypothesis of mu1 minus mu2 is greater than 0. One-tailed two independent samples t-tests with a lower-tailed rejection region have null hypothesis of mu1 minus mu2 is greater or equal to 0, and an alternative hypothesis of mu1 minus mu2 is less than 0. The next step in our hypothesis test procedure is determining a decision rule, as well as finding the associated degrees of freedom for the independent samples t-test. Our decision rule will be the level of significance, or alpha level, we are choosing to test at, with a common choice being alpha is equal to 0.05 that we have seen in previous hypothesis testing procedures. The degrees of freedom that are associated with your two independent samples t-tests are found by adding the two sample sizes, or sizes of the two groups being compared, and subtracting 2. This formula can be represented as df, for degrees of freedom, equals n1, or the sample size or group size of the first group, plus N2, or the sample size or group size of the second group, minus 2. Now let's look at the formula for finding the test statistic in a two independent samples t-test. Our formula for t is x bar 1, or the sample mean from the group you have designated as 1, minus x bar 2, the sample mean from the other group, minus mu1 minus mu2, or the hypothesized population mean difference, over the estimated standard error of the difference between x bar 1 and x bar 2. To calculate the components of the t-statistic, we need to first calculate the estimated standard error of the difference between sample means. To do so, we can calculate the pooled variance, which is the most accurate estimate of the underlying population variances based on a combination of the two sample variances, but we should only pool the variances if it can be assumed that the two underlying population variances from which the samples came are equal. When you are conducting your two independent samples t-test using SPSS, the software will calculate each of these components for you, as well as the t-statistic, degrees of freedom, and p-value associated with the test statistic. SPSS will actually calculate separate test statistics when equal variances of the two populations are and are not assumed, with the choice of which to use being dictated by your data. Our next step will be making a decision about the null hypothesis. Similarly to previous hypothesis tests, we can make a decision about our null hypothesis by comparing our p-value to our chosen alpha level. If your p-value is greater than your alpha level, you would fail to reject or retain the null hypothesis. This would indicate your test results are not statistically significant based on your alpha level. If your p-value is equal to or less than your alpha level, you would reject the null hypothesis. This would indicate your test results are statistically significant based on your alpha level. Remember that when conducting your two independent samples t hypothesis test using SPSS, the software will calculate an exact p-value that corresponds to your two independent samples t test statistic. The last step after you make your decision will be interpreting your decision based on your hypotheses and research question.